When you're doing solubility product expressions and some other types of problems, you may run into some math that you haven't had a lot of need for. So I want to make sure that we all know how to solve expressions with large exponents on your calculator. Hopefully this video will be a little less controversial than my last how to use a calculator video, which blew up the internet. So I'll try to be nice this time. So here's an example of an expression that might fit the description that we're dealing with. You might do a solubility problem that comes out to some weird thing like this. So let's just be real careful with our PEMDAS. Remember, the first thing we want to do is parentheses. So we have a parenthesis here and then an exponent. So this is, we want to square 2x. The commonest, is that a word? The most common mistake people will make here is they would square this and call it 2x squared, but that's not 2x squared, it's 4x squared, right? Because you got to square both of the things inside. And similarly, this is not 3x cubed, this is 27x cubed, because 3 cubed times x cubed. And the right side doesn't change. So now we've got 27 x cubed times 4x squared, so we're going to multiply the coefficients, which I hope is 108, because that's what I'm going to say it is, and if I'm wrong, I'm going to look silly on the internet. And then the x's are x squared times x cubed is x to the 5th. And that gives us this expression. And now we've got to solve that. So we're going to isolate the x. First thing we're going to do is divide out the 108. And I'm not going to try to do this one in my head. So 8.2 times 10 to the negative 15th divided by 108 is 7. So x to the 5th equals 7.593, we'll call it, times 10 to the negative 17th. Now this is the point where I figure that some of you might need some help. What we need to do is we need to take a 5th root of this side to get x, right? Which means we need to take a 5th root of this number. So 7.593 times the negative 17th, we need to take a 5th root of that number. So there's a few ways to do that on your calculator. And the first way that I'll discuss is taking a 5th root. You know that a square root is equivalent to that number to the 1/2 power, right? Well, a cube root is equivalent to the 1/3 power, and a 5th root is equal to the 1/5 power. So you can always just raise this to the 1/5 power if you want. That's one way to do it. That's usually how I would do it. So I have this number on my calculator already. For this particular calculator, there's the x to the y button here. So I can take that answer and raise it to the 1/5 power by, I don't know if I saw what I did there, but I put a parenthesis, 1 divided by 5, close parenthesis, and that gives me 5.97 times 10 to the negative 4th, which is the right answer. So, like I said, there are other ways to do that as well. There is the arbitrary root button, and that button is the shifted form here. It says x square root there. And so the way that you would use that button is you would tell it which root you wanted to take. We want to take the 5th root, and then we would need to shift this key because it's the above there. And so we want to take the 5th root of the number 7.59 times 10 to the negative 17th, and there we are with the same answer again. So that worked as well. So you can raise it to the fraction power, or you can take the root an arbitrary root there. So what did that look like on a calculator? Different calculators look different. You're gonna have to play around with your calculator to see how to do it. On this calculator, the way it's gonna work, this is your, both keys are done with this little caret button. So if I wanna raise it to the 5th power, I'm gonna 7.59 times 10 to the negative 17th. And then I'm going to raise it to the 1/5 power. You can just type 0.2. And there's the same answer again. It's not in scientific notation, this number this time, but it's the same number. And then the root button is that same key but shifted here. So if I wanted to take the 5th root of it, I'm going to go 5th root. It's the little X radical key, shifted usually, of 7.59 times 10 to the negative 17th. And there it is. We get the same answer again. Now, so this is how you do it for the 5th. For a 3rd or a half or a 7th, you would just do the same thing, substituting those numbers for where I used a 5 here. So that's how you can take. That's how you solve expressions with large exponents on your calculator by Mr. Atkins.